For centuries, Mars has captivated our imagination, a distant, rust-colored beacon beckoning us to dream of new horizons. But what was once the realm of science fiction is rapidly becoming the blueprint of our future, thanks to one company, SpaceX. They aren't just planning a mission. They're designing a pathway to make humanitarian species. Today, we're diving deep into the technical heart of that ambition. We'll explore the colossal machines, the groundbreaking strategies, and the daunting challenges that lie ahead as we prepare to become the pioneers of the Red Planet. Hi everyone, Liam here. You are fascinated by the engineering of the future. Subscribe and follow for more science, natural, and cosmic content. The very core of SpaceX's Mars plan is one colossal vehicle, Starship. This isn't just a rocket. It's designed as a fully reusable interplanetary transport system. Imagine a stainless steel skyscraper standing over 120 meters tall and stacked atop its first stage. Super heavy. To put that in perspective, it's taller than the Statue of Liberty and significantly more powerful than NASA's Saturn V rocket, which took us to the moon. At the core of this plan is a simple goal: to make life multi-planetary, and Starship is the key. Its groundbreaking feature is full reusability. Elon Musk has stated that if you want to send millions of tons of cargo and millions of people to Mars, full reusability is not optional. Super Heavy. The booster stage is powered by an array of 33 Raptor engines, each producing immense thrust. After lifting off, it performs a complex flip and burn maneuver, returning to the launch site for a precise landing. Starship itself, the upper stage, then fires its own 6 Raptor engines to achieve orbit and continue its journey. This reusability is foundational. Without it, Mars colonization simply isn't economically feasible. But how does Starship, a vehicle designed to carry over 100 tons to Mars, get enough fuel to make the journey? This is where perhaps the most crucial and technically challenging aspect comes in orbit refueling. A single Starship launching from Earth, well, you're gonna have enough propellant to get to Mars with a useful payload. So, SpaceX plans to launch multiple Starship tankers into Earth orbit. These tankers will then rendezvous and dock with the Mars-bound Starship, transferring thousands of tons of super-chilled liquid methane and liquid oxygen. SpaceX leadership has highlighted that propellant transfer in orbit, especially cryogenics, is an incredibly hard problem, but it is fundamental to the Mars architecture. This process, known as cryogenic fluid management, has never been done on this scale, involving ultra-cold propellants that boil off easily in space. It requires precise docking, fluid transfer, and minimizing propellant loss. A typical Mars mission might require anywhere from 4 to 8 tanker flights to fully fuel the primary Starship. Once fully fueled, that Mars-bound Starship will then depart Earth orbit, beginning its long 7 to 9 month journey to the Red Planet. Arriving at Mars presents its own set of unique and formidable challenges. Starship will perform an audacious belly flop atmospheric re-entry, using its broad surface to slow down, followed by a vertical landing burn with its Raptor engines. This precision landing is vital, not just for the crew and cargo, but for setting up the foundational infrastructure. Once on Mars, the mission shifts to in situ resource utilization, or ISRU. This is where Mars becomes a gas station and a hardware store, not just a destination. The primary goal is to produce propellant for the return journey to Earth, meaning no need to launch return fuel from Earth. The process uses the Sabatier reaction to combine hydrogen, extracted from Martian water ice, with carbon dioxide from the atmosphere to produce methane and oxygen. Engineers on the project explain that ISRU isn't just about saving launch mass, it's about enabling indefinite operations on Mars. Without it, you're constantly resupplying from Earth, which isn't sustainable. This capability is a cornerstone of the entire plan. Without the ability to make fuel on Mars, every trip is one way, and sustainable colonization remains impossible. With propellant production underway, the next critical phase is establishing a permanent, self-sustaining outpost. The early starships will primarily deliver cargo, pressurized habitats, power systems, scientific equipment, and crucially, life support infrastructure. Life support on Mars is a complex engineering challenge. The Martian atmosphere is unbreathable, radiation levels are high, and temperatures fluctuate wildly. Early habitats will likely be inflatable modules or repurposed starships themselves, buried under Martian soil for radiation shielding. Experts in the field emphasize that it's not just about the rockets, it's about keeping humans alive and sane for years in a hostile environment, far from home. That requires robust systems and incredible human resilience. Future Starship missions will then bring more cargo and eventually the first large crews. These pioneers will begin building greenhouses for food production, advanced drilling operations for water, and more extensive power grids, likely leveraging solar arrays or even small nuclear fission reactors. The long-term vision is a self-sufficient Martian city, capable of supporting a growing population independently of Earth. While the vision is clear, the path to Mars is fraught with enormous technical and logistical challenges. Radiation protection from cosmic rays and solar flares remains a critical hurdle. Global dust storms can last for months, potentially crippling solar power arrays and communication. And the psychological impact of extreme isolation and the immense distance from Earth cannot be overstated. The timeline is ambitious, while early targets were set for the mid-2020s. Most current analyses suggest the late 2020s or early 2030s are more realistic. Elon Musk has reflected on the difficulty, noting that this is the hardest thing humanity has ever done. There will be failures and setbacks, but the goal is considered too important to give up. SpaceX's plan for Mars is a bold tapestry woven from cutting-edge engineering, audacious vision, and sheer human will. From the fully reusable Starship to the complex ballet of orbital refueling and the ingenuity of producing propellant on an alien world. Every technical detail is a step towards a future where humanity is no longer confined. The journey will be long, difficult, and punctuated by both triumphs and setbacks. But the foundational work being done now is laying the groundwork for what could be the greatest adventure in human history, the transformation of our species into citizens of the cosmos. As we look to the red planet, we're not just seeing a destination, we're seeing a new beginning. Hi everyone, Mark here. If you are fascinated by the engineering of the future, subscribe and follow for more science, natural and cosmic content. And let us know in the comments, when do you think humanity will finally set foot on Mars?